Our topic is building the backbone, powering the next wave of AI infrastructure. Um, I am actually going to read notes for the first time, so I do not discount how incredible these women are. So I will kick us off. So I'm Lauren Baccarello. I'm the Chief Marketing Officer at WECA. We are the world's only storage system purpose-built for accelerating AI. If you are trying to make your GPUs work harder and smarter, come talk to us. We're out there. That is the only thing I will say about WECA for the entire panel. Okay, first up, we have Bink. Bink leads data center capacity strategy at Lambda, and she spent 3 decades riding the wave of computing infrastructure from biotech systems architecture. From biosystems architecture to team leadership roles and infrastructure at Google, Meta, Yahoo, Microsoft. She's delivered a data center infrastructure that's powered everything from scientific discovery to search to social to advertising to AI. She was from Meta's first dedicated AI research cluster to Microsoft. She's led requirements for multi-billion dollar supercomputers. So clearly, she has absolutely no experience in building data center strategy. I think we will have an incredible conversation. Up next, we have Carmen, who's the founder and CEO of Silicon Data, a company transforming global compute markets through data transparency in financial grade infrastructure. In October 25, Ms. Lee was also appointed CEO of Compute Exchange, an independent marketplace that enables transparent, efficient, and scalable trading of GPU compute. So if anyone thinks they're busy, she has 2 CEO jobs. No,
Maybe one is not enough, right?
one's not enough. And when you say women like to multitask, we're like, let's just swap between companies in the same breath. And last and certainly not least, we have Elisa Chen. She is a data scientist with over 5 years of experience in the AI industry, which is incredible because AI is about 4 years old. So she is one of the pioneers in everything that is happening. She's on the team at Meta doing AI infrastructure, building out the foundation that powers all of their machine learning models that serve ads to hundreds of millions of users every day. She's done research in neural network compression techniques and is excited to solve complex, large scale infrastructure issues. So, is anybody else here dealing with hundreds of millions of users? I wish I was. That is absolutely, absolutely incredible. So, we're going to start off with a super easy question. Um, so, Elisa, we often hear that AI infrastructure moves slower. It moves slower than technology. So much of what we are doing in this pace of AI innovation, your physical hardware, your infrastructure is something that like holds you back. What are you doing? How do you think about overcoming this?
Yeah, that's a great question to start. And stay tuned for my talk later on the main stage. But just to tee up everyone to the topic itself, I think there are like a couple of ways to go around this. Like, number one, you actually do have a couple of other supply levers other than just incremental supply that you order. That comes maybe like every 12 plus months. On top of that, you can also like leverage elastic supply. This can like lead, for instance, you can leverage GPU as a service, like resources. You can also like build your elastic resources yourself in house. There's also a lot of like efficiency levers. So, not all of your workloads, like especially like training, once you run a job, it can be freed up to do other things. And, you'll learn to sort of figure out what are some of like the efficiency techniques that you can use. Um, then that turnaround will sort of like improve your system utilization moving forward. There's also like swap contracts that you can leverage. We've got to make sure that like our quota allocation is dynamic. That's something that is like not always easy to do because you do need to have a very flexible forecasting sort of like um, mechanism, and also like good telemetry to make sure that like you can sort of monitor that headroom and like future usage properly. But that can inform like how you might adjust your quota appropriately from like workloads that you know don't need as much like GPU to the ones that will need more like compute or storage power. So those are like a couple of other like levers that you can use for your supply. On top of that, I would say that like there are also you do your planning in different tiers. You have your short-term planning and also your long-term planning. So in short-term planning, you actually like go and talk to like your customers, understand the needs. Your like ML AI researchers, understand what projects they're going to be working on, and like understand like what kind of experiments they're running, what are like the results that they're seeing in like let's say like model compression, or just acceleration like results, and then based on that you can kind of like see how much you might want to need like in the short term. But then you also need to do your like long-term planning, and that sort of like accounts for information at the org level, like your big bets, your strategic sort of like I would say play that you want to do like for the next 5 to 10 years. And that you don't have a lot of information for that, but I think you can sort of like inform your just strategy, I guess, like based on what you hear in the market, like what are some of the new hardwares that are coming out, what are some of like the frontier research that is done, what are like the new state of the art models that are coming out, then those can inform some of like your AI strategy in the future. So that's like a TLDR in terms of like what you might think about for bridging the gap between these two cycles.
That makes a lot of sense. And Bing, I know we had an incredible conversation about this, and the hardware just takes longer to come out with new hardware. Infrastructure and physical infrastructure is different. How do you think about, the infrastructure side and physical infrastructure?
So, so there's a couple of approaches. One is that everybody's pretty familiar with the constraints. The thing that we're running into now is that if you look at it for keeping up with every single iteration that's going to come your way and the appetite for every single iteration, you're going to have a problem because you can't build fast enough to keep up with that. And so the challenge that's emerging is, okay, so how do you slot for that? And so one of our challenges is going to be evolving a modular approach that lets us look at making sure we have the right capacity at the right time. And I don't see it slowing down. Infrastructure data centers are going to get faster, but they're not ever going to be as fast as the hardware is going. And the hardware is not going to be as fast as the applications are going. So at some level, you're also looking at it as a layered strategy. And this is something actually, at least did a great job. I don't have much to add on that side of how you think about forward projection, but I would say the other thing that comes in is layering your approach with the idea that not everybody is going to need the bleeding edge all the time. And so um, keeping a very close eye on what you're doing and making sure that where headroom comes up, you take advantage of it, and being conscious that you need to understand kind of what the workloads are doing, and then you have an opportunity to sort of retune.
Oh, and then Carmen, as you think about GPU capacity and how hard it is to get and find GPUs right now, what are you seeing in your world?
Yeah, I think both of them. Hopefully, can you hear me? I think both of them hit on really good points. I love that everybody keeps saying this is moving too slow. I was like, this is moving really fast for me. I feel that the Huang's law every year, I think it's pretty fast. I don't know what you guys expecting. I think everywhere new chips. So the way Silicon Data do is we publish GPU index on Bloomberg and Refinitiv. So they're actually going to be a futures option trading on those indexes. We're 6 months delayed. Obviously, we need data. Every year popping out a few indexes to catch up. And then there's AMD, have newer ones, NVIDIA's and other providers, right? So there's a lot of things going on every single layer, and every single layer of GPU changes will trigger the CUDA libraries and other, the everything else up the stack will change, right? Will get better, but it's going to take time. So I feel like yours is very fast. Number two is I agree that given I think moving really fast world, having flexibility is gonna be really, really important, right? How do you know this chip gonna satisfy all your customer needs in year number 3? How do you commit to certain chips, certain infrastructure, certain workflows, right? having flexibility, I think will be critical. I think user wants that. I think company wants that. So how do you do this multi-cloud, even different chips, different sort of workflow thought process? I think planning going to be critical. How do you do reserve capacity? Do you do 5-year long contract? Do you do month to month? Do you do on demand? They all come with different volatility pricing, different challenges. Obviously, most of compute exchange clients are our Series B, Series C, Series D startup using tons of compute. They're looking for the reserved a lot of different nodes, not just on-demand compute testing 1 GPU at a time. So that requires planning, right? So that's my 2 cents here.
Yeah. And it's so interesting because so much of it requires forward thinking planning. We know what's going to happen in 3 years, in 5 years, in 6 months. But so much of the reality of the world that we live in is I don't really know what next month is going to be. How should people in the audience start thinking about, yes, I need planning for 5 years, but I need agility because maybe I'm doing a ton of training today and then all of a sudden I switch to inferencing or my user base explodes. How should they start thinking about that?
I think from my perspective, like number one, you will never be at like a 95% utilization for your like capacity. That's like a dream state that you will probably never reach. So there will always, I think, be a gap between like what you're actually using and like sort of just resources that are sitting idle. But I think there are a lot of like use cases for those resources as well. Like you will run into sort of like operational spikes. You will maybe have like projects that are below the line or new experiments that you can run. There's always, I feel like, additional use cases for these like resources that are not necessarily used immediately, but can serve. Okay, as I mentioned, like previously, you can build your own elastic pool that can sort of like serve these like ad hoc workloads as well. That's like one, I think, lever that you can like use to I guess use your resources more efficiently.
I doubled down on that. The one thing that has proven true over and over again is that there's peak load, and then there's how fast you need to deliver, like how just how wide does the pipe need to be in terms of data delivery and computation, and then there's okay, what can I actually live with? And that's going to be, as the applications are evolving and given everything that's happening with the algorithm improvements that are being discussed and all the optimizations that the various contributors to the straight up hardware are doing, this is going to continue to change and efficiency will continue to increase, but you're always going to have that lever of being able to investigate and interrogate your workload and your needs for how fast that computation needs to run.
Yeah, I think there's two pool of clients we're talking about here. One is enterprises. They may be like 60% utilized. I literally have a conversation yesterday with head AI for one of the largest Fortune 500 company. He was like, "How do I monetize my GPU clusters when they're not in use?" I was like, "What do you want to do?" He was like, "I also love CPU too." I was like, "Don't even worry about CPUs." I was like, he's like, "Can I do multi-tenant?" I was like, "Wait, what? You want to
Got all
solve
the
the
buzzwords with
world's?"
you.
I was like, "Do you want to solve the the hardest problem right now?" Like, it is a lot. So I think for the large companies, right, they do have those, the underutilization problem, right? So I was like, you can run benchmarks. I don't know. We can talk about this. On the other side, you have startups who needs more compute. They couldn't source compute fast enough. No one will rent them B200 month to month, right? So like think about those like imbalancing of demand supply curves we're talking about. So that's I keep talking about like, hey, do your reserve what you really need to get done, right? You kind of know that, right? Do reserve contracts. For the things that, make sure it's flexible. Can you do on demand? Can you do multi-cloud? Can those nodes be, can you trust them to spin up nodes very quickly, right? And then also have the transparency, right? Before you take on those nodes, can you just verify before you bring on the workloads, transfer the workloads? So all those things I think can be critical.
Yeah, I'll touch on the verification piece. One of the things that Lambda is really priding itself on is delivering functional. AI hardware has proven to be one of the more difficult things to land with quality. And that's something that we're going to need to continue to watch, not just us, but as an industry, because it matters a lot. And in terms of that run from you have a facility ready to accept equipment to that equipment being used, the quality of your hardware is a very big piece of that, and being good at making sure you can mature that quickly is a superpower.
Can I double click on
Go.
that? So one of the things I think smaller companies dealing with right now is the transparency piece, right? So one of the things is say, hey, I'm gonna run MLPerf on my cluster. I think I'm great. Look at my results. It's great, right? But again, it's not third party verified. Or you can donate your cluster for a month to some third party and they run it, right? And then you don't have transparency on that. But a month is a long time for expensive machines. And you're the money you're not making. So one of the things we do, not to promote this, but some banks use us to do machine level verification. So let's say I'm gonna refinance my 100 nodes. Then Silicon Mark comes in, we verify it's a on-premise SaaS, it's a container with a container, you can run us. Well, 90 seconds, we'll tell you all the UIDs, all the information, and banks is like, okay, third party verify it, check. This is what this performances, this is the potential decay for curve, and this is how much money I think you can be, refinanced. So things like that I think will be very helpful, just transparency wise.
I think it makes a lot of sense. And then something you touched on that I want to dig into more is this idea of like what's really required, what kind of speed, what kind of performance is really required in terms of output. Because as you've said, GPUs are expensive. What are you using? How are you load balancing between this is the new hot technology and this is now a couple of years old? And how quickly do we really need what type of results? If I'm asking, where's the AI Infra Summit? I probably need that answer like in a quarter of a second because I'm lost somewhere in Union Square. But if I ask, can you redesign my dining room? Maybe I don't need that in a quarter of a second. So, how are you thinking about this idea of what's required in terms of performance from a user perspective? And then, how do you build an infrastructure that allows this idea of we're going to put this resource here, that resource there?
So that's an evolving story. The position we've set up for our customers right now is that we are adjacent to every customer who we are working with to the best of our ability, modulo what can happen in terms of local power constraints and all the other issues. But I think the piece there is understanding for us, listening to our customers. We are not the ones who are dictating what that performance needs to be. We need to be prepared to meet their requirements, but it is a dialogue, not a go put yourself right out there right now. Okay. But a lot of the activity is in the US, and we are adjacent in most of the major markets that we need to be in.
Yeah, I would like to second that as well. I think doing sort of like user segmentation analysis can be helpful in this instance in just understanding your user behavior patterns. As an example, like if I just talk about like ads, you have your users who are more prone to like, let's say, click on an ad versus some others. And it also depends on like the country itself, because the pricing could vary a lot. So you might want to prioritize those customers who are more likely maybe to click on an ad or buy something afterwards. But then on top of that, you can also like think about how you might want to do like model to hardware like mapping, just depending on like the stage you're at in the model development lifecycle. So your like foundational models and training needed for that, you might want to rely on more like those dense GPU clusters. But then for fine tuning, and like once you have your foundational model, like when you do distillation or like other sorts of fine tuning, you might want to rely on like those like A100s, not as sort of like dense as your H100s. But then, when you think about like inference, which is a lot faster, you might not necessarily need the, top of the shelf machines to do that. You can potentially, if you're willing to like, there's always a trade off, I think, between like latency, model performance, and sort of like the, trade off between these two. I think if you're willing to let go, you can, I think, get a lot of bang for your buck during the inference stage. And I think there's a lot of flexibility there as well. You don't need like the top of shelf, I think, to do inference itself.
I'm gonna throw in another piece, which is cost. Right. I think sometimes depends, right? If you're looking for like now, you might willing to pay a high cost versus hey, I'm okay to wait for a month. I want to create a movie. I don't care. Do it off peak time with electricity cheap. There's a lot of compute nodes here. The inferencing infrastructure platform may even charge you much lower for batch, right? So cost versus quality versus latency, you can't have it all. But pick what's important to you, right, at a given moment. So, have that transparency again. So make an informed decision. And at least you have an option, right? So that's important.
I love that you brought up cost. I'm going to do an audience question right now. Do you know how much you are spending on your AI infrastructure? Do you know what the relative costs of the output of what you are, the models you're running, the programs you're running, and the AI you're building? So, what's fascinating about the world we're in right now is how do you measure cost? What is cost? What is the value of what you're doing? Is the cost your GPUs? Is the cost your tokens? Is the cost the number of queries that you're able to do? So I would love to talk about that first big macro question. How should I even think about cost?
I actually have a talk later, talk about the cost. Again, really agnostic side, right? We don't host any models. It's really purely from pricing point of view, because we have token index. Is one thing we do keep track. Like, do you always need the latest, greatest model? Maybe it's maybe not. Maybe you want to use those open source models where give you more deterministic, faster. There's no thinking involved a lot of times, right? Not much thinking involved. So it really depends on the total cost aside from the token. There's human costs, right? There's other, but everything else is much lower compared to the actual token cost and input output token. We can talk about all those things, but yeah, in general. So I think another thing people don't consider is the human piece. If you keep running something, right, the human being, you're expensive. Engineers are very expensive. So that's one of the things I want to highlight. She's very expensive.
Well, maybe I'll be replaced by AI in a few years. Yeah, I think that makes a lot. I agree with that. There's a lot of like hidden costs that are not necessarily discussed. Just to echo on that, there's also a lot of like fixed costs. Let's say in power and cooling, like running data centers. Those are really expensive as well. That are not necessarily accounted for when you're. But this might also be applicable only to bigger companies as well. Yeah.
So for wearing my pre-Lambda hat, cost is opportunity cost. Okay. So in the mode that I am seeing conversations happen right now, and this is not me speaking from direct engagement with Lambda's customers, at least not yet. When you have a clear value proposition, it becomes much easier to justify what you need and where. But I think our company has to be very conscious of the cost that Elisa mentioned, right? Working with our colo providers, to get our capacity, potentially building in the future. All of those things are a financial game as much as they are a physical constraints game. And so being intelligent in terms of picking the right infrastructure at the right time in the right place, that's our best bet in terms of managing cost, because our customers are then going to influence what we need to do next.
Maybe just to add on to that, I really like that idea. I think something else that we don't have a good sense of is like, what is the ROI of our capacity? Like, how do we measure the sort of like upside of using our capacity that is very expensive? That's not always easy to measure either.
I would say margin is hard to measure to begin with. The ROI is even more challenging. We don't have costs, and yeah, it is very. The whole chain is very murky at this point. Yeah.
And from an ROI perspective, should I be thinking about, is it the number of tokens that we're generating if we're doing inferencing? Should I be thinking about how many users I can support simultaneously? Should I be thinking about GPU utilization? And this idea of what is the currency of AI? And if I'm an enterprise, how do I know how to understand if this is good or bad?
I think it does vary, I think, depending on the machine itself as well. I think token is like a very common cost, I would say, unit here. But then you also do have, let's say, like your, network cost, IO cost, or your storage cost, which could be measured in terms of like, your petabytes. So I think the unit varies a lot depending on what type of machines we are talking of. Yeah.
Yeah, I'm going to go back to the opportunity cost discussion. And Elisa, I learned, I did my basic training in that at Google. So, but I think the issue there for an enterprise is understanding, I don't know, it sound like a broken record, understanding what you need to do. What is AI going to accomplish for you? That dictates effectively your input understanding of what it's worth and then what you're prepared to spend.
And I would just caution, I think, what doesn't matter what metrics you pick, just know that what doesn't any metrics have blind spots will lead you to a path that may not be the right path. If you do token output, not all token the same quality. And the precision can be different, right? Like the longer the output doesn't mean it's better, right? Another thing I will caution is utilization. How do you precisely measure that as well, right? So if I were anyone, I would try to measure. I will be a hoarder. I will measure everything, and then we'll try to triangulate and then see what kind of thesis I come up with. As a business owner, right? What I do when I have an AI product is I'm not concerned. Maybe it's the wrong thing to do. I'm not concerned about cost. I'm concerned about output. I'm concerned about will my user pay for this, right? Once they prove its validation, I was like, okay, let me try to lower the cost. My default is let's use the best, the latest and greatest. Once I achieve what I want, we'll break the workflow down into different models. We'll try to test different things. But right now, I'm not concerned about cost.
So you brought up a couple of interesting things. This idea of like, what are our blind spots? What are the things we don't know yet? And there's also a piece of this that is there's only so much new here. There's only so much new. We are building infrastructure for AI in the world that did not exist years ago. So there's some blind spots in that, but there's only so much that's new. There's a lot that's pattern recognition. So I would love to talk about, okay, what is new, and then what are the shoulders of giants that we should be standing on instead of creating from scratch? And then Bing, I'd love your take on it.
So, and Lauren, we talked about this a little bit. History doesn't repeat itself; it rhymes. The idea that you have an application that's being developed is consistent. What you tune and develop in making that application more appropriate, more efficient, more effective, that is a sequence of actions that is going to repeat itself over and over and over again. And so, from that perspective, I mean, in some ways, I have it easy, right? Because I can look at it from the standpoint of what space we need to allow for from a capacity strategy perspective. But then I am going to sit back and watch what happens and see what the developments are. And that's not any different than the way we've done this for the 30 years I've been doing this. So it is an opportunity to really go back and say, okay, what is truly new, unique, different, difficult? Okay. Understand those in the macro so that as you go through, you have an opportunity to maximize on where you really need to put the attention. And if you need discipline or experience with that, there's lots of people who have talked through how to do this. So, and that for me is comforting. All I have to do is make sure I have enough capacity ahead of you.
That's all.
I like that idea. I will say though that there are very unique challenges though with AI development specifically. Like we don't have, I think, a very robust evaluation framework. Like we don't know what is a good, like is our model performative? Is it doing what we are expecting it to do? How do we test that? Because it's not a deterministic output. You might, put in the same input and you would get a different output each time. So the development cycle, I think, on a macro scale, I agree it is the same. But there are a lot of, I think, nuances specific to this industry that I think we don't have all the answers yet. What are like the key solutions to this? I don't have the answers to it either yet.
Yeah, I kind of echo both of them. So silicon data is really built on premise is borrowing some existing industry infrastructure. So think about, if you're American airline, you need to hedge your oil prices for obvious reasons. You go to futures market, right? You buy and sell oil futures, right? It's very transparent, easy, cheap. You can do whenever you want. You don't have to call OPEC, say, hey, give me 5 year long contract. It's ridiculous. You and me can go to futures market, right? We don't have to be American airline. It's the same access for everybody, right? If you look at compute world, if you treat compute as a human resource, that's completely different game. It's so much more opaque, right? You have to call someone to know someone, you're dealing with this. It's not transparent at all. You lock in a long-term contract with hyperscalers, guess what? You want to back it out, you get fined, right? It's very, very different. If you treat that as a commodity, they should have a more robust financial infrastructure to support the whole industry's growth, right? So then the results will be lower the cost of capital for everybody in this room, will benefit all the consumers at the end. If a data center provider is paying 20% interest on their GPU clusters, guess who's paying at the end? It's everybody here, right? If they can't hedge their volatility, guess what's happening in the end? We all pay for the volatility, right? So we have to borrow a lot of ideas which try and true for every other sectors, commodities, corns, and everything else, and try to replicate it for compute. To your point, it is different. Compute is not a commodity. That's why silicon data is normalizing all GPU clusters. It's over 100 configuration of H100. How do we normalize to a base case, which make the index a lot more relevant and high correlated? Doesn't matter you do neo cloud, hyperscalers, marketplaces. It's still something you can hedge your cost structure, right? So we're borrowing the traditional market sense with the new AI challenges. So that's why we're here too.
Let's talk.
The something that when Bink and I were talking that we sort of laughed on was the pattern recognition, and this looks like. I remember when the internet was the early days of the internet, and it was just coming out, and this whole idea of caching was there, and it was again, where where is this hotel in Union Square? This is a question that has been asked before. And in the early days of the internet, every time you ask that question, search engines would be like, I don't know. Where is that hotel? And you'd have to go through, and they discovered this thing on caching. And then I look at AI right now and how we are working and how we are running workloads. A lot of it is this recompute every time, and how we can think about how do we leverage a cache? How do we leverage memory in a different way? I would love to talk about that and what you're seeing in terms of caching and memory and how we can use this to accelerate AI innovation. And then what other things are we seeing that it's like, wait a second, this looks like this. How can we leverage this?
I think you're spot on.
Yeah.
It's one of the new slide I'm putting into my. I'm not joking. I'm like putting a new slide about caching.
Yeah.
But maybe I should leave to you. But
Yeah.
this is critical. I don't think many people are thinking about caching, not doing as much recompute. I don't think even know they're doing recomputing. That's how do we do that? How do we know that, right? So that's the first step. But 100% agree with you on this point.
I'm going to play the newbie card for where we stand in Lambda's approach. But I think the challenge here for us will be to stay ahead of what's required, right? And as I said earlier, our customers are helping us understand where they think they need to go. And that is going to be something that, from our position in the market, that's something we have to respond to.
I want to also offer like a point of view from the flip side. So I think like long context models are becoming like more and more crucial, especially for like deep research or like thinking. So I think memory itself, like we are becoming more efficient, I think, with memory usage. But at the same time, I think there's another force that is like demanding more memory from these models as well. So I think it's like a counterbalancing act that we're seeing.
I think you're completely right. And there's this idea of sort of simple complex. Where is this hotel in Union Square? Probably can sit in a cache. The help me redesign my dining room and let's go back and forth. And I would like Scandinavian modern. No, I want Danish modern. And what's the difference? That probably is going to need a different way of thinking about this. And that's one of the things that I think is really interesting about the world of AI and AI infrastructure is you have to build for both the simple scenario and the extremely complex scenario.
Couldn't have said it better.
Yeah.
And that hasn't changed whether it's been hyperscaler or what I'm doing these days, right? And we're early in.
Mm-hmm.
We're all going to be learning. We're all going to have to be on our toes and hoarding data and paying attention to what are the opportunities and then where do we need to double down in order to really fine tune. And as a capacity planner, that's always been true. To go back to where we started, right? You have your min bar and you have your max bar, and you're going to be working within them. And the idea is to control just how can you stay within those bars, because that's how you're dictating your cost structures in most cases as a provider. But understanding where you have opportunities to dramatically improve things.
I think that's the fun part. Nobody knows. So that's really so. If you are aggressive learner, you're steep learning curve. Everyone can be a winner. So I love that. Like just completely reset the playing field. No one knows, right? So I think that's really I think what I love 2 jobs at this point, right? So it's really fun. You see the synergy, it's connecting dots, and you see things people don't see it. That's really the next generation of ideas and business opportunity will come.
And I think a lot of that is how do we all build that competitive advantage? And everyone here, does anyone here not have any competitors? You're a market of one. I wish I was in that world. I think we all wish we were in that world. It'd probably be a little bit less fun. But how do we think about using our infrastructure to be part of our competitive advantage so that we are the trifecta of better, faster, cheaper, and maybe instead of pick two, you get all three?
It's a very tough question.
I'm gonna wear my TPM hat for a second. Better, faster, cheaper, and consistent and predictable.
That is an excellent call out.
Yeah, and I don't have an answer for this one yet. I'm very, very curious to see where it's going to go. It's one of the reasons I'm here today is to understand what the challenges that people are grappling with, and understand how it potentially translates into the sort of 3D reality that I also live in. So,
I think the industry is still at its like trial and error phase. There's a lot of experimentation that we're still doing within the space. So, yeah, there's not I feel like single clear answer as of this point.
Yeah, I would say transparency, right? Because no one knows. So really start being very mindful of how you flow those metrics up, right? Be very honest with the systems and utilizations, and everything else going on. I think transparency was the key to at least know where you are and why you suck, right? And how to get better.
And something that I like, I like about this idea of transparency and digging into the data and the metrics is this idea of how can you use that to find the bottlenecks to performance. And so much of infrastructure 20 years ago, infrastructure today is what are the bottlenecks? What are the choke points that are making things harder? How do you think about removing bottlenecks, accelerating development?
There's so many bottlenecks, and every single day is different bottleneck. I don't know. Go ahead.
well, and having done a fair amount of performance benchmarking, you chase the bottleneck. What is true one day or even 1 hour? You make a tweak, an adjustment, you decide to tune your parameters, and it may be something else because of the nature of the algorithms that you're running and the nature of the the models have a defined path, but inference and the way we look at potentially chaining inference, we don't know yet. We just don't know yet. And so transparency is my stock and trade in terms of understanding what's going on. Because if I see something, like if I have the observability right, then I have an opportunity to double click on the things that don't make sense.
I think at this stage, the best that you can do is set up like a really good data foundation and really good telemetry, and hire like the right data people to do the sort of like analysis and build out the funnel and like the life cycle view that you need to understand where the bottlenecks are, because as you guys mentioned or y'all mentioned, the bottlenecks change every day.
That's why it's fun and different, right? We have to make it fun, make a big giant game. So we do track supply and demand, and because we're a data company, right? So for us, is everyone knows energy is a bottleneck for America, but no one mentioned energy is not a bottleneck for other countries, right? But other countries may have, network bottleneck, right? They might not have enough network or switches, and they might have this, but then guess what? Packaging become a bottleneck for some country because they can, and then other things, solutions and ASML things going down, right? Every single piece, because the market, the whole supply chain, for a lot of parts, is a winner takes all. If something falls off, and every single person down the chain got impacted. So that's why I keep saying bottleneck is different every single day, every single country is different, every single time is different. You fix this one out, and it is really fun. And at the same time, to have that kind of understanding, especially if your goal is if you want to be a great trader, right? Understand that will be pretty critical, and have the transparency to know that.
One of my favorite questions to ask, we've got this incredible room of people here, and we have these brilliant minds on our stage. What advice would you give to the people in this room about building AI infrastructure, setting up, breaking the barriers of what's possible is really hard? What advice can we give the people here to give everyone a bit of a leg up, make it slightly easier?
Go ahead, Lisa.
No, you go ahead. I was still thinking. Yeah.
So, experimentation here is key. Experimentation at a reasonable value, obviously, you want to strive for. But I think, and I said this, I think, before, understanding what you need to get out of the activity, like there's your thesis about what it will actually do and help you with. Make sure you're clear on that. And then go experiment to see whether or not you're getting the output that you're looking for. You can do a lot of these things on a smaller scale and still get very viable inputs to how it needs to evolve.
I love that. And for me, it's first principles thinking. It is before we just go, let's just buy a bunch of GPUs and throw things on it and see what happens. Let's start with what are we trying to accomplish? What do we want to do? What does good look like? And then build ways to figure that out, run small tests, rinse, repeat, keep going and expand. And even though AI is so new and we are the first minute of the first day of this, a lot of that same core first principles apply, whether it is how do I train the most advanced model possible, or how do I just get a basic agent up and running in my organization? So I love that. Go back to first principles. And then Carmen, what do you think?
Sure. Strategically, I'm always last to speak. I feel like I need more time to think, right? My token just generates very slow. Well, thinking token going on. So I would say just be obsessed. Love what you do, right? So I think nothing beats passion. Because you really love something you do, either it's model training side or inferencing and building agentic flows or hardware, GPU fine tuning, benchmarking, building data centers. Love it. And then you will want to learn the latest and greatest all the time. To me is almost, again, unfortunately a gigantic game. I'm trying to figure things out. It's just really fun. And the industry is good in a way. It's reset for everybody, but also weed out people very quickly. If you say, hey, I don't want to change my workflow, I don't want to do this and that, I don't want to the latest and greatest, I'm okay with the previous iteration models and skill set, you'll probably be, outdated in month 6, right? So everyone left. You will keep building up your edge. That's why I love this industry, because weed out people very quickly, and also you have to keep. Maybe I shouldn't, but you have to keep learning. That's the fun part, right? At least to me, it's the fun part.
I think that's awesome, and it is stick with your passion. Like if you're going to be great at something, if you're excited about it. Who here is passionate about AI? Okay, good. I was hoping the vast majority of people. Otherwise, maybe we're in the wrong. We found the wrong building. But it is, and it's find that passion in the things that excite you. You'll build great work And you'll find incredible connections when you follow your passion. I think that is advice we should use for our jobs and probably for everyday life as well. And last but not least,
I would say, just to add on to everything that they both have mentioned, yes, I think hiring the right curious and passionate people, but then also establishing the right collaboration models. I think this space is still quite new, and I think people are trying to figure out like what is the best way that we can work together. Like you have your AI like researchers, you have your TPMs, data scientists, like all sort of like typical business roles, but then you also have your business capacity or capacity planners, your vendors. Like how do all these people like come together, and like what is the best way that we can collaborate so that we ensure that things are operating smoothly, and we don't want the bottlenecks to be people.
So you mean one person can't do everything?
That is what I mean.
No, I think that's incredible advice for people. And it is, don't think it has to just be you. We all want to be the smartest person in the room. And or is there anyone who's a chief AI officer or VP of AI leader? Okay. This is going to be the crazy thing. It's not just you. You have this team of people around you across all different functions. And the beauty of it is how we work together to do more, to find great work, to find great innovation. I think that's phenomenal advice for everybody here, and probably building that community around you. So even if it's you internally, are there people like people in this room who you can network with and become closer with so you can bounce ideas off of? And again, this is the first minute of the first day. We are building the future of AI together. So leverage your community, leverage the people on stage to help you become even better at what you're already doing. So with that, I'm going to wrap up the panel and thank our panelists, and then leave everybody some time to network and meet each other and ask our panelists some questions before we go off to the next session. So please join me. Huge round of applause for these incredible women.